Hello guys, my name is Dylan. Welcome back to another video, and in this one we are going through paper 3 of the 2025 Key Stage 2 SATs Maths papers. You can see it here, look, 2025 paper 3. We've already gone through the arithmetic paper 1, we've already gone through the reasoning paper 2. Here is yet more reasoning. Let's dive straight into exactly how to answer these questions and what came up. Question 1, circle the numbers that have 8 in the thousands place. Well, we all know where the thousands place is. This has a 4, no. This has an 8, yes. This has an 8, yes. This has an 8, yes. And this does not, this has a 3. The trick here is that we have different number of digits in these numbers, and we need to know exactly where that thousands place is. Not just looking at the first digit that comes up and falling for a trap, but actually looking at the thousands place. Number 2. Tick all the numbers that are less than 1,050,000. Another place value question here. I would be writing out 1,050,000, knowing that the 5 goes in the 10,000s place. This is testing your understanding of that place value later down in the road, in the 10,000s, 100,000s, and million. Which of these numbers are less? Well, this is obviously more. This has 100,000s, so I'm going to leave that one. This is 49,000. I know that's less than 50,000, so I'm going to give that a tick. 60,000, well, that's more than 50, so I'm going to leave that alone. And here we have 1,030,000. Even though that's a 9 at the end, doesn't matter because that's in the hundreds. 30,000 is less than 50,000, so I'm going to give that a tick. You need both of those for a mark. Question 3. There were 15,961 people at a football game. Round this number to the nearest 100. Well, let's see. Our number up to the hundreds is going to give me 9 hundreds. I like to draw that wall in because that means I have 159 hundreds. I hope that makes sense to you because I can write it out like this: 159 hundreds or 15,900, same thing. And the next 100 would be 160 hundreds. And the reason I do that is because it can be quite hard sometimes to think what would the next 100 be, because it's affecting more than one place value column. In this case, it would be 16,000. So the answer is either 15,900 or 16,000. To figure out if we're going to round up or down, we look at the tens column. It's a 6. We're going to round up, therefore, and the answer to this question is 16,000. We've rounded it to the nearest 100. It doesn't matter there are 0 hundreds technically in our answer. It's still a multiple of 100. Therefore, we get the answer right if we put 16,000. Question 4. Jack buys 2 kilograms of pears. He spends £3.28. What is the cost of 1 kilogram of pears? This is as simple as taking your £3.28 and dividing it by 2. Why not just put it into short division like that to make sure you get the answer right? How many 2s are in 3? That's 1 with 1 left over. Put your decimal place in. How many 2s into 12? 6 times. 2s into 8 go 4. The answer is £1.64. Just as straightforward as dividing by 2. You might be able to divide by 2 mentally, which is great, but just make sure you get it right. There's no harm in using this space here just to do a little bit of short division. Point P is located at 5, 8 on the grid. We can see here 5 across from the origin, across the x-axis, and then 8 up. Point P is translated. That means moved. 4 units right, 6 units down, and 2 units left. So let's do that. 4 units right, 1, 2, 3, 4. 6 units down, 1, 2, 3, 4, 5, 6. And then 2 units left, 1, 2. So it ends up right here. The question says, what is the location of point P after these 3 translations? Well, we know we start at 0, 0. We go along the x-axis, 7. Then we go up the y-axis, 2. And we get the answer, 7, 2. Question 6. The mass of the empty truck, which we can see in the picture here, is 2,250 kilograms. Cool. It is then loaded with 8 boxes, and each of these boxes is 25 kilograms. What is the total mass of the truck and its load? Okay, so here we have 25 kilogram boxes, and we have 8 of them. So we're going to do 25 multiplied by 8. 5 8s are 40. 8 times 2 is 16, plus 4 is 200. So the boxes weigh 200 kilograms. We're going to add that on to the 2,250. Adding on 200 kilograms is simple. We get 2,450 kilograms because luckily for us, 200 kilograms was a nice number to add up here. The answer is 2,450 kilograms. Question 7. Draw 4 lines to match each improper fraction to its equivalent mixed number. You'll notice there are 4 improper fractions here, but there are 1, 2, 3, 4, 5, 6 mixed numbers. So we can't just match them up and know what's left. We have to work out each one individually. 26 out of 4. The way to convert this is to count whole numbers. And we count whole numbers in 4s because the denominator is 4. Every 4 quarters we get, we can exchange it for 1 whole. So how close can we get to 26 using the 4 times table? Well, 6 4s are 24, which would leave us with 2 quarters remaining. So we need 6 and 2 quarters, which is right here. So I'm going to match those up. Next one is in fifths. So we're going to count in fifths. And every time we have 5 fifths, we exchange for 1. How close can we get to 27? 5, 10, 15, 20, 25. We're going to have 5 wholes with 2 fifths left over. Do I have that as an option? Yes, look, it's hiding at the top. Going to match that up. 30 out of 4. We're back to quarters, back to counting in 4s. Well, 7 4s are 28 with 2 quarters left over. So I'm going to match this up with 7 and 2 quarters. And finally, 32 fifths. 6 wholes would be 30 fifths, and there'd be 2 fifths remaining. So 6 wholes and 2 fifths. That's down at the bottom, and I can match them up just like that. 4 and 2 quarters and 4 and 2 fifths were not needed, so we cannot just rely on process of elimination. We had to work out all of them using our technique. Question 8. Ken buys these 3 items. He pays with a £20 note. How much change does Ken get? Well, first step to this for 2-mark question is to figure out how much in total they cost. So we're going to have £2.50 for the cereal, £1.15 for the loaf of bread, and then 80 pence is going to go here for the milk. 5 in the 1p column, 8 plus 1 is 9, plus 5 is 14. Exchange over, put the decimal in, and then 2 plus 1 is £4.45. And then the real test here is doing change from £20 note. So a £20 note would be 20.00, and we're going to take away 4.45, £4.45. Now for this method, there's a lot of exchanging, which is fine if we're confident doing that. We'd exchange over here to get 10 in the £1. Now we can exchange over to the 10p column, and then finally we can exchange over to the 1p column. 10 take away 5 is 5, 9 take away 4 is 5. Put your decimal place in, 9 take away 4 is 5 again, and the 1 drops down. You get £15 and 55 pence change. There's multiple ways to get there. You could have done a number line counting on from 445 all the way up to 20 if that's something you're more confident with. That's down to your individual preferences that you need to try and decide. Whatever method you did, the answer should have been £15 and 55 pence. Next one, question 9. Here is part of a number line. Now, it wants you to tell you what number that the arrow is pointing to. So this is something interesting because we have 0 here. So straight away, you should be going, okay, what goes past 0 that way? It's going to be negative numbers. So I need to figure out how much each jump is worth. And luckily for us, we get given another number, which is 5, which means we can work this out. So 1, 2, 3, 4, 5 jumps to get from 0 to 5. So each jump is just 1. So we're going to count backwards. 1, 2, 3, 4, 5, 6. This is negative 6 or minus 6, depending on how you want to say it. Write the number that is 16 less than 7. Well, we could still use this. 7 is here, and we're going to count back 16. 1, 2, 3, 4, 5, 6, 7 gets us to 0. 8, 9, 10, 11, 12, 13, 14, 15, 16. It's this number. Well, what is that number? Well, the answer to that question is going to be, if we count on, minus 9. So we can put in our answer minus 9. You could have also done 7 take away 16. A trick answer, again, a lot of people might fall for, is to just put 9 because they did 16 take away 7. No, this is 16 less than 7, which is 7 take away 16. We're going to march down into those negative numbers. Question 10. Here is some information about 4 animals in a zoo. Tick the statements that are true. The elephant is exactly 3 times heavier than the rhino. Well, the rhino is 2,400. If we multiply that by 3, do we get 6,300? The answer is no. Straight away, just multiplying the 2,000 by 3 is 6,000. Then I've got to multiply the 400 by 3 is 1,200. That's going to be way more than 6,300. That's not true. The hippo is a quarter of the height of the giraffe. Well, the hippo is 1.5 meters tall and the giraffe is 6 meters tall. 1.5 multiplied by 4 does equal 6. So it is a quarter. We're going to tick that one. That's for sure. Next up, the rhino is 20 centimeters taller than the hippo. Well, the rhino is 1.7 meters. Bear that in mind. And the hippo is 1.5 meters. If I change this to centimeters, I get 170 centimeters and 150 centimeters. And now I can very clearly see that is 20 centimeters. So I'm going to tick that one as true. And it says here the tallest animal is also the heaviest. Well, the giraffe is the tallest and is definitely not the heaviest. So we're going to leave that blank and get 2 marks for ticking those 2 statements. Question 11. Tick the number sentence that is correct. So out of these ones here, which one is correct? I think the best thing to do, given that it's starting in decimals, is to change these ones on the right hand side to decimals as well. 4/10 is 0.4, 4 in the tenths column. 3 thousandths is 0.003, 3 in the thousandths column. You'll notice here the 3 and the 4 the wrong way around. This is incorrect. Next one, 0.43 is 43 thousandths. Well, let's think about thousandths for a second. We've got tenths, hundredths, and thousandths. So if I've got 43 thousandths here, the 3 will go in the thousandths, the 4 will go in the hundredths, but we have to put a placeholder in the tenths. So this again is incorrect. Next one, 4 in the tenths column. I've got that. That is 0.4. 3 thousandths. That would be 3 in the thousandths column. Look, I've got it. Tenths, hundredths, thousandths. This one here is correct. We can just double check the one at the bottom. 3/10. So the 3 would go in the tenths column, which it isn't. So that's wrong. This here, knowing how to convert from tenths, hundredths, thousandths into your place value is key to answering these types of questions. That's for sure. Question 12. Each clock below shows the time in either AM in the morning or PM at night or in the evening or afternoon. Match each clock to its 24-hour time. The first one's been done for you. So this here we can see it's 5 minutes past 4. It's in the morning, so it's 04:05. Let's look at this one. It's in the afternoon and it's past 12. So it's going to be 12 something because it's in the afternoon. If it was in the morning, it would be 00. And we're going to see how many minutes have gone past the hour. Well, this would be 30 minutes. So another jump is 5 minutes extra. So this is 12:35, which means we can join up that one there. Next one. Here we have AM, so that'll be important later. But firstly, let's think. The hour hand has just gone past the 7. So it's something past 7. And how many minutes is it? 1, 2, 3, 4 jumps of 5 minutes. So this is going to be 7:20. And because it's AM, we put a 0 at the front because it's in the morning, first thing. And that means we can match up 7:20. The trick here would be 19:20. That would be PM. You've got to read this very carefully. And down here, we have PM. It's in the evening. It's not quite at 11 o'clock, so it's going to be 10 something. How many minutes have gone past? Well, this is 3/4, which is going to be 10:45. But beware. Do not think, wait, where is 10? It doesn't work. No, guys. It's PM. So in a 24-hour clock, we have to add on 12 hours to make sure it's in the evening. And we get 22:45, which now matches up nicely there. So again, it's got this extra one here to try and trick you. No, you need to be really sure and be watching those AM and PM times to avoid those traps. Question 13. Write these numbers in order, starting with the least. Again, when we're comparing fractions, decimals, percentages, get them all into one version. I'm going to change these all into decimals. 9 hundredths is 0.09, 9 in the hundredths column. 99 out of 100 is 0.99. And you'll notice, I'm actually going to get rid of my crossing out because I'll need that later. But what you'll notice here is that some of my numbers I've written are 2-digit, well, both of them, and the rest of them here are 3-digit. So I'm just going to put a placeholder to make them all 3-digit. Now I can really easily compare them. So starting with the least, okay, what's the lowest number here? Well, this has 0/10, 9/10, 9/10, 0/10. What's smaller, 0.009 or 0.09? Well, this is going to be 0.009. This is tiny, 9 thousandths. So get rid of that one. Then it's going to be 0.09 because both of those have 0/10. So get rid of that one. And what I would do, to be honest with you, I would write what's given to me in the question, which is 9 out of 100. I just write that just to make sure. I know they're equivalent. It's probably fine, but just make sure, write what's in the question. Over here, 0.999 or 0.990. Well, clearly that 0 at the end makes it a little bit smaller. And then the largest one here, again, look, what have I done? I've written my conversion. I would just write what's in the question to be sure. They're both equivalent, so it's fine, but just write what's in the question. Then the largest one must be the 0.99 and then the 9,000ths as well. So when we're comparing fractions and decimals, get it all into one format because then it's much easier to do that comparing. Question 14. Look at this expression, y plus 4. Tick the value for y that gives a prime number when you do y plus 4. So what about when y is 8? Well, let's swap that in. We'd get 8 plus 4, which would give me 12. So this is 12. Is that a prime number? No, it has multiple factors. Y equals 9. Well, that would be 9 plus 4. That would get me 13. Is that prime? Yes, it is. So we could tick this one and be done. We can just double check because 10 plus 4 is going to give me 14. That's even. It's got multiple factors. It's not prime. Down here, tick the value for y that gives a square when you do y plus 4. Okay, 5 plus 4 is going to be 9. And that's a square number. You can tick it and move on if you're super confident. You can check the rest. This will give you 10. This will give you 11. These aren't square numbers. Square numbers are found when you multiply a number by itself. 9 is 3 squared. 3 times 3 is 9. So you could tick that and move on very quickly. An easier question, I think, compared to some of the other ones we've seen. A factory makes t-shirts and dresses. They pack them in boxes just like this. There are 50 t-shirts in a box. How many t-shirts are there in 250 boxes? So what we have here is 250 times 50. Now here's how I do this. I would split 50 into 250 multiplied by, I'm going to split it into 2 of its factors. 5 times 10. Okay, so 250 times 5, we can do short multiplication to get this one and make sure it's right. And we end up with 5 times 0 is 0, 5 times 5 is 25, and then 5 times 2 is 10, add the 2, 1,250. So we've done this part. And then multiply it by 10 is so easy. 1,250 multiplied by 10 is 12,500. That's going to give us our answer. And I did that just by splitting up into factor pairs. Now let's take a look at the next one. There are 40 dresses. How many boxes are needed for 3,000? So in this case, we're going to take 3,000 and divide it by 40. Again, I'm going to split 40 into its factors because we're dividing. We can do this. 3,000 divided by 10 divided by 4 because 10 and 4 are factors of 40. 3,000 divided by 10 is 300. Now I've got my divide by 4 left over. Whack it into a short division bus stop. 300 divided by 4. How many times does 4 go into 30? Well, it goes 7 times, is 28 with 2 left over. How many times does 4 go into 20? It goes 5 times. So we would need 75 boxes. So up here, we were multiplying, had 250 boxes. Down here, we were dividing by 40. Either way, we can simplify multiplication and division by getting factors and using that. So multiplying by 50 is the same as 5 and 10. Dividing by 40 is the same as divide by 10 and divide by 4. Made these questions much, much easier. Question 16. These pie charts show the biscuits in 2 tins. Tin A has 36 biscuits and tin B has 20. That's going to be important. Tin B has more chocolate than tin A, more chocolate biscuits. Explain why this is incorrect. Well, we can see why maybe you would think this. Because in tin B, half a chocolate, but only a third of chocolate in tin A. And we know a half is larger than a third. But it's the total that's making the difference here. Tin A is much larger. So to explain why this is incorrect, what you would have to do is, for tin B, you would have to do half of the total, which is 20, which equals 10. And then for tin A, you would have to do 1/3. Let me just write tin A, 1/3 of 36, which is 12. This is enough to prove it. Okay, so when you're doing these explanation questions, you can do a bit of maths and that's enough to prove it. And then you could do a sentence here that just says, therefore, there's more. 12 is more than 10. So there's more chocolate biscuits in A than in B. But the key here, to explain and prove something, you can do maths to do that. Okay, it's very important to show you're working out and prove it using something you've calculated. A shop buys 35 boxes of crisps. Each box contains 48 packets of crisps. So we've got 48 packets in each box and 35 boxes. Sounds like multiplication. Let's keep reading. On average, the shop sells 56 packets of crisps each day. How many days will it take for the crisps to be sold? Okay, let's work out firstly how many individual packets the shop has. And to do that, we're going to do 35 multiplied by 48. So we're going to do a long multiplication here. Let's do top row multiplied by 8. 5 times 8 is 40. And 8 times 3 is 24. Plus the 4 that I've exchanged over here in my head. That gives me 28. So we have 280 there. Now this next line is going to multiply by 40. Put the placeholder in so I can multiply by 4. 4 times 5 is 20 with the 2 exchanged over. 4 times 3 is 12. Add on that 2 is 1400. So then let's add these together. We have 1,680 packets of crisps. It sells 56 a day. So how many days will it take for all the crisps to be sold? Well, let's do division. We're going to do a long division now. 1,680 divided by 56. So again, just like in the arithmetic paper we've gone through, when we're doing long division, we actually build up a little bit of a fact box here, adding 56 each time. Let's just do 3 and see if we need more in a minute. 56 into 1 doesn't go. 56 into 16 doesn't go. 56 into 168. Look! It goes exactly 3 times using my repeated addition to find multiples of 56. So I can actually straight away take away 168, say that's 3 lots, that's 0 left over, drop the 0 down, there's nothing left. That's it. I put in my placeholder, because being careful that still we have to put there are 0, 56 and 0 here. Take away the 0, that's it. Done. So it would take 30 days. And that is how to solve this question. You need to be proficient at using long multiplication and long division. And luckily for us, it was a very nice set of numbers where actually we only had to get 3 lots of 56 in our little box. Well done. Question 18. Convert 5.65 kilometers to meters. You need to know that 1 kilometer is equal to 1,000 meters. So 5 kilometers is going to be 5,000 meters. But then you've got your 0.65. So the 6 comes next, the 5 comes next. But if you left it like that, that is not 5,000. I know it has to be 5 in the thousands column, so there's a placeholder at the end, which is 5,650 meters. It is key for these types of questions that you know those facts, because if you don't know 1 kilometer is 1,000 meters, you're going to find it really hard to answer that question, essentially. Convert 35.5 centimeters to meters. Again, for this, you need to know that 100 centimeters is equivalent to 1 meter. So instead of multiplying this time, which is we got a bigger number, we're actually dividing. So to get from centimeters to meters, we have to divide by 100. And luckily for us, dividing by 100 is quite straightforward because we just move the digits down 2 places because there's 2 placeholders. So let's think about 35.5. The decimal doesn't move, but I'm going to move the digits down 2 places. I did not mean to do that little line there. Let's get rid of that one. Let's move down that 5 here 2 places. 1, 2. So the 5 is going to go there. This 5 goes down 2 places. 1, 2. And the 3 goes down 2 places to the 1s and then to the tenths. So we actually have 0.355. We can put a placeholder at the start to do 0 point, and we get 0.355. And look what's happened when I wrote my number. My 3 has kind of gone over my decimal, and it's not clear anymore. If that happens, very, very, very clearly, put a big decimal in there, okay? That's super important, because if someone sees that and isn't sure, you're not going to get the mark. And we don't want to miss out on silly marks like that. Question 19. Jacob has some wooden blocks that are all the same size. He uses the blocks to make 2 towers. The height of the tallest tower is 22 centimeters. So what's the height of the smaller tower? Classic 2-mark question here. First job, we need to work out what's the height of each small block. And we can do that by having 22 divided by 5, because there are 5 blocks. We're going to go into decimals, but that's fine. 5s into 2 don't go. 5s into 22 if I exchange over. 5 times 4 is 20, and there's 2 left over. So what we can do is put a decimal and a 0, and that 2 exchanges over here. The decimal comes up to make sure we don't forget that. How many 5s in 20 is 4. So each block is 4.4 centimeters tall. Therefore, this smaller tower is 3 lots of that. So I do 4.4 I multiply it by 3 because there are 3 blocks. 4 threes are 12. Put your decimal in. 4 threes are 12 again, which is 13. When I add on my 1 I exchanged, and we get 13.2 centimeters for the height of that one. Classic 2-mark question, dividing down to get one lot and then multiplying out. It's almost like a fraction of an amount question. Question 20, I love this question. I thought this was very interesting. This shape is made from equilateral triangles. What fraction of the whole shape is shaded? Now, this is the kind of question you could actually get in a year 4 lesson. It's a hard question, it's a hard version, but what we have to know here is that in order to write a fraction, the parts need to be the same size. We have to have equivalent parts, and there's a problem. This is a very small triangle, this is a very large triangle. So the best thing I would do here is to draw in the smaller triangles for each of the larger ones. That's what I would be doing. Just like this, just roughly. I know it won't be exact for me because I'm just drawing this on my computer, and for you it might not be exact, but you get a rough idea. You will know that there are this many small triangles inside of each big one. So now we've done this, we know that one part is shaded, and it's not just going to be one part of however many I had to start with. I know now I've created equal sized parts. So I can count them up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 small parts. It's 1 out of 16. Now, if I didn't draw this in and I just had something like this, a classic answer that I think a lot of children would have put would be 1 is shaded out of 1, 2, 3, 4, 5, 6, 7. 1 out of 7. And this would be very, very wrong because it shows a lack of understanding that each part has to be the same size. So drawing in like this may have been very useful to understand this question properly. Question 21. Here is some information about a number. It has 2 digits. It's a multiple of 7. One of the digits is 8. Write all the possible numbers that it could be. What we're essentially saying here is it's in the 7 times table. So let's do our 7 times table and see which ones have 8. 14 doesn't have 8. 21 doesn't have 8. 28 does. That's the first one I'm going to write in. Now, have you noticed something? Okay, have you noticed something? It's testing your 7s again because it knows children struggle with them. So you have to know your 7s to be able to access this. 35 doesn't have an 8. 42 doesn't have an 8. 49 doesn't have an 8. 56 doesn't have an 8. 63 doesn't have an 8. 70 doesn't have an 8. 77 doesn't have an 8. Let's keep going. 80 something. This will obviously have an 8. So the next one is 84. So I've got 84 here. And traditionally, in our times tables we learn, we would stop there. And a lot of children probably would stop there. They think, oh, I've got 2. It's a 2-mark question. That's all good. No. Let's keep going and just double check something. Add another 7 on. We get 91. Add another 7 on. We get 98. So this is not traditionally in the 12 lots of 7 we go up to, but it still counts. It has 2 digits. Yes. Is it a multiple of 7? Yes. Multiples of 7 don't just stop at 84. One of the digits is 8. Yes. A lot of children will have missed this one out and only got 1 out of 2. If it's asking for multiples of 7, don't just stop at the times tables you've learned. You must keep going. Question 22. This diagram shows 4 identical parallelograms and a rhombus. It's very important to understand that these parallelograms are identical. Okay? So, calculate the size of angle A. Well, first off, if we're given this angle in the parallelogram, opposite angles in a parallelogram are equal. So this is 115 degrees. Okay, that's a fact. Now, we could, because we know all of these parallelograms are equal, all of the obtuse angles are 115. Nice, we can put those in, 115. But it doesn't kind of help us very much, because realistically, to work out angle A, I need to work out what this angle is, which is the same as this angle here. So how can I work out what that angle is there? Well, there's a couple of ways you could do it. All of the angles inside of a parallelogram, a quadrilateral rather, that's 4 sides out of 360. But also there is a quirk of parallelograms that the 2 different angles will add up to 180. Okay, so 115 added on to 65 would give me 180, which means this is 65. And if you were to add up all 4 of these angles now, it would give you 360. So we'd have 65 plus 115 is 180. 180 plus 180 is 360. Which again means I can label all of the smaller angles 65 degrees. So I can now finally do my calculation. I know that angles on a straight line is 180. I'm given 65 as one of the angles, 65 as another angle, and angle A, which is what I'm trying to calculate, as the missing one. So I need to calculate this. 65 plus 65 is going to give me 130. I can do 180, take away 130, and I have got a 50-degree angle. Now, there are multiple ways we could have gone about working this out. Okay, lots of different ways. However, it's key to understand the intricacies of angles in different types of shapes, and especially a parallelogram. Knowing that opposite angles are the same is important. Knowing that they all add up to 360 is important. Knowing that the two different angles add up to 180 could have been important. And then also combining this with knowledge of angles on a straight line. So much pre-knowledge you have to have here and to unlock the answer to this question. A very tricky problem-solving question, I think, but a good one, I would argue. That's the end of the test. Okay, so it's the last question there. It's going to be tricky. Well done if you gave it a good go. Guys, like this video, subscribe for more. We've got plenty more on the way. Leave us a comment down below which question was the hardest. And as always, I'll see you next time for another video.